Right, let's come back and see the next question. That is your ninth question. Now, in ninth question, again, as I said, when it is a 2 marks question, they'll be giving you 2 questions to solve. Right, what is the question given? Now they start giving you reactions. What happens when? Why is this like that? What is like that? What are the products when formed? So this question, it says, what happens when orthophosphorus acid is heated? Okay, first of all, you should know what is orthophosphorus acid, otherwise it will be a problem for you. So what do they give us? Orthophosphorus acid is heated. So this reaction is called thermal decomposition reaction. Thermal decomposition reaction. Okay, done. So this thermal decomposition reaction, so we will write that. So orthophosphorus acid is nothing but H3PO3. Then they said it is heated. So when it is heated, it's going to decompose, right? So just a simple reaction which they gave me, heat, right? Now immediately this thermal decomposition, it dissociates into 2 important products, that is phosphine plus this goes to the higher oxidation state H3PO4. Right, so now the impurities what are present here, okay, I'm writing that also. The impurities which you get in this reaction is P2H4 diphosphine. Right, that also is the impurities. Now, so this H3PO3 orthophosphorus acid, that is phosphoric acid. Now you need to balance. They have asked in the question, they have asked to balance the reaction. They've not given, but you need to balance the reaction. Keep it. So here, if I balance now 4 here, just see here 3 3s are 9, 10 11 12, 4 3s are 12. Phosphorus is 4, phosphorus is 3 plus 1, 4. Hydrogen is 4 3s are, oxygen is 4 3s are 12. Here oxygen is 4 3s are 12. So this is a thermal decomposition reaction of orthophosphorus acid. Very, very important reaction where you are preparing phosphine, right? Now, when I come back to the next reaction, so this is your first reaction, this is second. What do they give me? HCF6 undergoes complete hydrolysis. There are 2 reactions which I taught you already. There is one partial hydrolysis product and one more is complete hydrolysis product. So both are there. So let's see. In complete hydrolysis, what do you get? Yes, let's see. Yes, so first in partial hydrolysis, let me take xenon HCF6. They said here also same. Here also when it comes HCF6 only. Now in partial hydrolysis again we have water. Here in complete hydrolysis also we have water because addition of water, right? So you have to remember in partial hydrolysis you get HF. Here also you get HF. But what is the difference? In partial hydrolysis you're going to prepare XeO3 as a product. No, XeO3 is there. You'll prepare a product called XeO4. Right, now in case of complete hydrolysis, you'll be preparing a product called XeO3. That's it. So have they asked anything? Nothing. They have just asked you to write the products. So simple. Now you need to balance the reaction. So if you are trying to balance the reactions, hydrolysis 3. Okay, when I take 2, I think this will be enough. So 3 to the 6. That is 3 to the 6 here. Hydrogen. Now if I take, okay, here when it is 3 to the 6, this should be 6, isn't it? This will be 6. So now see, 3 to the 6, 6. Fluorine is 6, 6. Xenon is 1, 1. Oxygen is 3, 3. So it is balanced. So you need to remember when it is partial hydrolysis, you get xenon oxyfluoride. Here you get XeO3, xenon trioxide. So remember that. Right. So let's come back and see the 10th question. So what is this question asked? They have asked us find what is oxoanion of chromium which is stable in acidic medium. So I need to write the oxoanion. Here I've discussed this concept of oxoanion in your transition metal elements also. Please go to that topic which I've already done, oxoanions of chromium. Right. So they've asked me to write. So in acidic medium, the stable oxidation state of stable thing is Cr2O7 - 2. So I did this video, you can watch that. Next one, lanthanoid element that exhibits +4 oxidation state. Okay, lanthanoid, directly you need to go to the lanthanoid series. So lanthanum, lutetium, we have written, isn't it? In that they said which exhibits +4 oxidation state. Right, here cerium exhibits +4 oxidation state. You can directly write this answer. Cerium exhibits. I also did one video on oxidation states of lanthanides, so please watch that. Any question may be asked from any point, right? Next, 11th question. What did they ask me? Give the IUPAC name of the product formed. Okay, this is one way of questioning you, IUPAC nomenclature. So they said 2-methyl 1-bromopropane is treated with sodium and dry ether. So sodium and dry ether, you need to remember This is only in Woods reaction, isn't it? So Woods reaction, you always take two similar alkyl halides. Remember that. So whenever you see this sodium in dry ether, you have to be very careful that it is Woods reaction, right? So after writing the product, you need to name. There is a concept. So 2-methyl 1-bromopropane. So what is the parent chain? Prop. 1, 2, 3. Prop. In the second carbon you have 2-methyl. So this is 2-methyl CH3. This is CH3. This is CH3. This is H. 2-methyl 1-bromo. So this is 1, 2. So they said 2-methyl will start from here. 1-bromo. So let us write CH2Br. Okay. So 2-methyl. This is first carbon. Second carbon. 2-methyl 1-bromo. Propane is treated with Na. Okay. In the presence of dry ether. So when they say dry ether, immediately you need to write, take the second mole of this, exactly the same, because it is Woods reaction, isn't it? It happens in between symmetrical or similar alkyl halides. So I'm going to take CH3 here also. So fill in hydrogens, and this is H. This is over. So take out NaBr from this. Okay, you can write this Br here also, not a problem. You will write Br here. Then this becomes 1, 2. So this is CH3. Done. So what are you going to do? You're going to take minus NaBr. So this whole thing happens in the presence of dry ether. So join that. What product you get? 1, 2, 3, 4, 5, 6. In the second carbon CH3, and again in the fifth carbon you have CH3. Remaining all hydrogens. Right? Now name this compound. They want you to name this compound. Now start naming. 1, 2, 3, 4, 5, 6. So what is this? 2,5 dimethyl, this is dimethyl hexane. So the IUPAC nomenclature is 2,5 dimethyl hexane. That is the product. Okay, that is what is the question asked. So this is capital letter. So 2,5 dimethyl hexane. That. This is also over. Now what should I do next? I have to do the next reaction. So because the place I have written it there, they've asked me 1-methyl cyclohexene is treated with HI. I did one video where I explained the reaction of HI with alkenes, unsymmetrical alkenes also I showed you, symmetrical alkenes also I showed you. You have to be careful. Now what did they give me? Write the structure. 1-methyl in the first position. This is a cyclohexene. Okay, so this should be hexene, and there is at the first position there is methyl group, it seems. So this carbon 1, 2, 3, 4. Okay. Now, what did I add? I have added HI. Okay. Now, I said unsymmetrical alkene, you have to be careful while writing this. What product do you get? This bond breaks and you are going to get a compound in this way. Methyl group here and iodide also here. So, let us start naming this compound now. And what is this? This is the first position. First, second, third, 4, 5, 6. Name this 1-methyl. Okay, that is what is the question. Yeah, 1-methyl. 1-methyl, 1-iodo. Let me write that. 1-methyl, 1-iodo, cyclohexane. Okay, this is what is your IUPAC nomenclature. So I've written, hope I've completed everything. Yes, all the question, whole question is complete. So 1-methyl, 1-iodo, cyclohexane is a product which is formed. So you have to be very careful in naming. So let me come back and do one more question. Why? Because from 11 marks, 11th question, all the 3 marks questions. So you will have the third question also here. Right, let's go back and see the third question of third part of the 11th question. So what did they give us? Chloroethane is treated with AgNO3. You are supposed to write the IUPAC nomenclature for this. So chloroethane. So write the formula C2H5Cl. Right, now it's treated with AgNO3. So take the silver nitrate. So what happens? AgCl is out, minus AgCl. What is left now? This is going to form C2H5NO2. Okay, so this is the IUPAC nomenclature, nitroethane. That's it. That's the compound. Simple. Right. Now here they've given one question. So you're supposed to write, what did they ask me? They said you're going to find, okay, let us write what data is given to us first. So here in the given data, yes, the freezing point of benzoic acid decreases by 2.12. Okay. Delta TF is given to me, that is 2.12 Kelvin. Right, now what is given to you next? They've given you when 2.5 grams of benzoic acid is dissolved in 25 grams of benzene. Okay, they've given me also the weight. Yes, weight is equal to 2.5 grams, right, dissolved in 25 grams of benzene. Solvent also is given. Weight of this is solute, and weight of solvent is 25 grams of solvent. This is also given to me. Next, what else is given to me? They said calculate Van 't Hoff's factor. Okay, I need to calculate its sums. Okay, kf also is given to me. Kf is given to me as 5.12 kg per mole. I have written this data. Now after writing this data, let me write what I need to calculate. Van 't Hoff's factor. What is Van 't Hoff's factor? I need to find I. Okay, I also need to calculate and percent association. So percent association also I need to calculate. Now let's start. So according to the formula with the given data, what actually is the formula which we already learned? Delta TF with the Van 't Hoff's factor, I into your KF into molality. Molality, this is what we have written. Now substitute the values. Delta TF value, how much is delta TF value? 2.12 is equal to I need to find out I into what is KF value given to you? 5.12. Now molality we have already studied. Number of moles divided by weight of the dissolved, isn't it? Number of weight of the solid dissolved in that particular weight, that amount weight already given. So if I have to write volume also is given to me, so I can write it as 1000 divided by your 2.5, that is what is given. Yes, 2.5 into the molecular weight by molecular weight, isn't it? Number of moles, so that becomes here 122 molecular weight. So when I solve this I value, I get an answer of, if I have to solve 5.2, okay, if I solve I get an answer of 0.05. this is what is your I value. Now molality, okay, number of moles I already took that, but given solution, volume of the solution also I took. Now with this I need to find the percentage. So what is the formula for I which we took already? I is equal to 1 minus alpha by 2. This is for your association which we did also already. I value, how much did I get? 0.505 minus 1 minus alpha by 2. Okay, now alpha if I take out, if I solve this, cross multiply this, I get 0.99. Okay, this is your answer. So what is the percentage of association? If I have to write, the percentage of association of benzoic acid is 99%. 99% is associated. Let me explain again. I have written this. I have taken the formula for this. So number of moles, weight by molecular weight also I did, then volume also I related, then I got to an answer. That answer I took this formula because they've asked me percent association. That percent association I have written, then I value I took it as 0.505, 1 minus alpha by 2. So that alpha by 2, alpha degree of association I found, I got an answer of 99%. So how is your weightage given to you? For the first formula or this one which you wrote, this particular one, you get half mark. Okay, now after that the substitution of this one, this whole thing which you did, you're getting 1 mark for this. Okay, now after that your association value, you got this formula, isn't it? This is for half mark which you have got. After that you got alpha value, this is again half mark, and final answer, that 99% which you have written, isn't it? Percent association, this is half mark. Let me count. This is this half and this half 1, this half and this half 2, this one is 3. So 3 marks is the answer. Step 1, step 2, step 3. Right, let's come back and see the 13th question. Again, 13th question, because it is for 3 marks, you'll be having 3 1-mark questions in this. So here what do they give us? Explain the following behavior. Okay, please remember, try to attempt all the 3 questions in the exam. If you don't know, okay, just try to, let's see that you're attempting the concept at least. Don't leave any question. Here they're given us alcohols are most soluble in water. So whenever you find the word solubility, or whenever you find the word boiling point, the key word which you should use is hydrogen bonding. So here, where is the hydrogen bonding? When they see the question, you first important thing is they've given you alcohols are soluble in water, then hydrocarbons. So answer you will be writing, the keyword is due to hydrogen bonding between alcohol and water. This is the concept. This is what is alcohol and water. This is your hydrogen bonding. This is important to keep. So because of the hydrogen bonding, they are soluble in water. Done. So they've given one more question. Orthonitrophenol is more acidic than orthomethoxyphenol. Very careful here. Ortho. Here is nitro, here is methoxy. Now you need to speak in terms of nitro group and methoxy group. Here, when I have to speak about the first case, here nitro is which group? Electron withdrawing group. Here methoxy is what? Let me write that also. Methoxy is electron releasing group. Now what is the speciality? When you have electron withdrawing group, it tends to drag the electron density towards itself. And when it tends to drag the electron density, what will happen to the phenoxide ion which is formed? It will become stable. So write down here, nitro is an electron withdrawing group. Write it in full form, and hence stabilizes phenoxide ion. But here in this case, what is happening? In methoxy, it's going on releasing electrons. When it's going on releasing electrons, that particular thing, the electron cloud will become more, and there's no drag, and there's no opposite poles formed, or you will not get even charges, dipole charges. But here, because of this electron withdrawing nature, it drags the electrons, and one phenoxide ion is formed, here one more. So your minus and plus. So this will stabilize the phenoxide ion. So this is your key answer which you should write. Right. So now what should you next question? Cumene is a better starting material for phenol. So we have studied one reaction where you're taking cumene. To that cumene you're processing, you get cumene peroxide. From cumene peroxide, what are you preparing? You're preparing acetone, right? Remember. So cumene, as soon as you see why is a better starting material, you're going to write from cumene, it's going to form. Even if you don't remember the reaction, not required. You can write that particular sentence, you'll get mark. It forms cumene peroxide. From cumene peroxide, this is going to form acetone. This acetone is a very important organic compound which is used as a starting material for many reactions. So it's used to prepare acetone, which is an important organic compound. So because of this, because we are preparing acetone from this, we are calling cumene as a better starting material. Right, let's see the next question. What did they give me? The rate constant of the first order reaction is 60 seconds. Okay, they've given me rate constant K. Right, how much time will it take to reduce 1 gram of the reactant? Okay, 1 gram of the reactant to this. So initial concentration of the reactant R0 is this, and after the process of the reaction during certain time interval, the reaction concentration has become so much. What should I find out? I need to find rate T. Right. So for the one, as soon as such question is given to you, you need to first see whether it is first order rate equation or first order rate reaction or second order rate reaction or zero order or pseudo first order. So here they've given me first order. Simple, isn't it? Directly I'll write the formula. What is the formula? 3 is equal to 2.303 K log of initial concentration of the reactant by final concentration. This is the thing. Now let us write the data. What data is given? I need to find T. How much is the rate constant? K value given to me is 60 seconds. R0. How much is R0? Given initial concentration is 1 gram. What is R? Given to me 0.0625 grams. Now substitute simplest numerical, which is for 3 marks in. Basically your numericals will be very easy. Don't get confused. Though I made you do a lot of numericals, they'll give you easy numericals only. Right. T is equal to 2.303 by how much is K? 60 log of how much is R0? 1 divided by what is R? It is 0.0625. So when you solve this, T value, you get equal to 0.0462 seconds. So this is your answer. I already showed you how to do log value, log A by B. Okay, please see that video where I showed you how to solve log problems. Right, let's see this question. Easy question now. What they give us? Solutions of two electrolytes A and B are diluted. Okay, both are diluted, it seems. But here on dilution, what is observed? This is A, this is B. Okay. Now, they said the limiting molar conductivity, that is this limiting molar conductivity, if I have to take not, what is that? The limiting molar conductivity of B has increased by 1.5 times, and while that of A has increased by 25 times, it seems. Okay, what do they want us to know? They said which of the two is a strong electrolyte. Justify your answer. So if I say the strong electrolyte is B, let me write. So now what happens? B is a strong electrolyte. Now ma'am, how did you judge that? I'll give you the reason. Now first, as soon as you get, write this answer in this way and start judging. Now what happens when you're diluting A and when you're diluting B? Now as I see this molar conductivity, it is 25 times increased. That means on dilution, the ions started moving. There's a lot of space between ions. The interionic attraction has become so much that the ions have moved so far, and hence on dilution the molar conductivity also increases. That is what is the question, isn't it? So they said if there's, I'm just reading it here, it increases for 25 times more, increase in the molar conductivity. Why is that? Right. So now what happened here on dilution? Seeing this, I'm answering. On dilution, what happened? Interionic forces or attraction, right? Interionic forces or attraction of the space between the ions decreases. Correct? When the interionic forces or attraction decreases, what happens? The molar conductivity automatically, when you see at that particular dilution, molar conductivity automatically increases on dilution. Molar conductivity increases on dilution because the spaces between them are far. When it is far, the molar conductivity also has become so much, the number of ions conducting current. So that particular, it has become 25 times more.